Hello.
So I think we can start our meeting. And first, I will introduce the AI, and later we will discuss what we are going to present while you guys come to Taiwan. And in the last part of our meeting, we'll discuss the third, fourth, and the fifth meeting, the dates of those meetings. Okay, so I'll first start my presentation of the introduction of AI. So can everyone hear my sound and see my PPT?
Yes.
Okay, so I'll begin. So today I'm going to introduce AI, artificial intelligence. And the introduction is mainly the summary of the class that we were in our first grade. And to start the topic, undoubtedly, what is AI would be the first question that we should ask. And AI is a big concept and discipline, which is the branch of the computer science. And it deals with the creation of intelligence agents, which are the system that can reason, learn, and act autonomously. And essentially, the definition of artificial intelligence is the theory and development of computer systems, which is able to perform tasks normally require human intelligence. And the types of AI can simply divide it into two. First is weak AI, and weak AI is also called narrow AI or artificial narrow intelligence, ANI. It is an AI that trained and focused to perform specific tasks. And weak AI drives most of the AI that surrounded us today. And narrow might be the accurate descriptor for this type of AI, as it is anything but weak. And it enables some very robust applications such as the Siri that we all know, or the Amazon Alexa, and others autonomous vehicles. And the second one is the strong AI. Strong AI is also called as artificial general intelligence, general AI, and it is a theoretical form and target of AI, where a machine would have an intelligence equal to humans. And just like the robots that we know in the science fiction movie, it would have a self-aware consciousness that can solve problems, learn. And while strong AI is still entirely theoretical form, it doesn't mean AI researchers aren't also exploring its development. And in AI, data is the most important thing. So the data science is developed to be the tool to get the data. And additionally, it is the study of data to extract meaningful insights. And the definition of data science is combined math and statistics, specialized programming to uncover actionable insights hidden in organizations' data. And speaking of AI, two concepts often be mentioned. One is machine learning and the other is deep learning. And machine learning is the subfield of AI, and deep learning is the subset of the machine learning. And first, we're going to talk about machine learning. Machine learning gives computer the ability to learn without explicit programming. And two of the machine learning is supervised and unsupervised machine learning models. And the key difference between the two is they are labeled or not. And supervised learning model have input with the labeled data, and the unsupervised model input with unlabeled data. And here we can first clarify what is word label. The label data is a data that come with a tag like a name, a type, or a number. And unlabeled data is a data that comes with no tag. And first, we're going to look at the supervised learning. Supervised learning implies the data that is already labeled, just like what I just said. And on the right-hand side, it is the example of the supervised learning. In this example, we should first presume that we are the owner of the restaurant. And here we have a historical data of the bill amount and how much different people tipped based on the order type, whether it is picked up or delivered. Here, it is shown by the blue dot or the orange dot. Means blue means it is picked up, and the orange one means it is delivered. And in supervised learning, the models will learn from those dots and try to predict what the future value and try to predict the future value, and in this case is the tips. So here the model bill will predict the future tip amounts based on whether an order was picked up or delivered. And another classical example of the supervised learning is recommender system. E-commerce companies such as Amazon or the streaming sites like Netflix and social media platforms such as TikTok or Instagram, and even YouTube, among many others, make use of recommender systems, and they use it to make appropriate recommendation to their clients. And getting more deeper, you can see the overview of the supervised learning. First, in the supervised learning, they will first input the testing data, and here we call it as X, and we'll put it into the model. And the model will output a predictions through the algorithms, and the prediction they'll use is to compare with the expected output, which is the actual training data. And if there are difference, we'll call it as error. And the optimus targets of the model is trying to minimize the error. So different kinds of the learning algorithms have developed. And here I have found 4 kinds of classical supervised learning algorithms. And it is the one-row algorithms, decision tree, and k-nearest neighbor, and support vector machine. And now let's look at the unsupervised learning. It implies the data that is not labeled. And on the right-hand side is the example that an unsupervised model might try to solve. So here we want to look at the tenure, which is the year of the company, and in the x-axis, and the y-axis you can see the income. And through all of these dots, the model will try to group and cluster it, which means there will for example, here you can see it divided into 2 parts. And by divided the past examples, we can see in the next time if a new dot come in, they can try to predict whether the employees is on the fast track or not, which means that we can know whether the employee is going to on the quick road to a higher position or not. And Due to its capability to uncover patterns in an unlabeled data set, unsupervised machine learning can be applied to image segmentation and classification problems. And here are the two features of the unsupervised learning. First is it can work without the need of human intervention, because unlike the supervised learning, we don't need to label it. And you can see the right-hand side is the process of the unsupervised learning. The data can directly go through the model and generate an example. And the second feature is that since unsupervised problems are all about looking at the raw data, which means they don't need to be labeled. So the unsupervised learning is its target is trying to group it into different group, and in this case we'll call it as cluster. And clustering is the most important process here. It is a data mining technique which groups unlabeled data based on their similarities or differences. And clustering algorithms are used to process raw unclassified data objects into groups represented by structures or patterns in the information. In short, the unsupervised learning are all about discovering. And in the different cases, it has developed different clustering algorithms. And here I find 4 kinds of the algorithms. It is the k-means clustering algorithms, the DBSCN clustering algorithms, and the agglomerative hierarchy clustering algorithms, and the divisive hierarchical clustering algorithms. And now we can get to the second concept. It is the deep learning. We can see again the graph. The deep learning is the subset of the machine learning that what I just introduced. And the definition of deep learning is that it uses the artificial neural networks, allowing them to process more complex patterns than the traditional machine learning. But what is the specifically differences between the machine learning and the artificial intelligence? And here we can see in the traditional machine learning, we need the human to do the feature extraction. But in the deep learning, through the neural network, we can eliminate this process. So all we need to do is just put the data into the computer. And deep learning uses the artificial neural network, allowing them to process more complex patterns than the traditional one. And it attempts to mimic the human brain through a combination of data inputs, weights, and bias. And these elements work together to accurately recognize, classify, and describe objects within the data. And the neural network consists of multiple layers of connected nodes, each building upon the previous layer to refine the optimize the prediction or the categorization. And the input layer is where the deep learning models ingest the data for processing, and the output layers is the final prediction. And the classical model of the deep learning is CNN, and CNN means the convolutional neural networks. And in the convolutional neural networks, it have 5 different layers. And first layers is the convolution layers, and Well, convolution layers can be followed by additional convolution layers or plugin layers. And the fully connected layers is the final layers in the CNN. And with each layers, the CNN increase in its complexity, identify greater portion of the image. And earlier layers focus on simple features such as colors and edges. As the image data progresses through the layers of the CNN, it starts to recognize larger elements or shapes of the object until it is finally identifies the intended object. And if you say it really simple, is that the convolutional layers and the plugin layers is just like the filter. It make the data become more simple. And the last one, the fully connected layers, is trying to map all the information and outputs and get it to the output layers, and we can get the final predictions that we want. And here is one of the example of the CNN. In this case, what the computer is trying to identify what number is this picture. So first we'll went through the convolutional layers and the polling layers is what I just said here. And it will make the data more simple and put it into a lot of different blocks. And the last but not least, the fully connected layers will arrange a answer to the output layers, and then we can know this picture is 2. So AI is simplest form. AI is the simplest form, and it is a field which combines computer science and data sets to enable problem solving. And it also encompasses subfields of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. And these disciplines are comprised of AI algorithms which seek to create expert systems which make prediction or classification based on the input data. And it is all of my introduction. Thank you. So are there anyone have any question or? Okay, so we can okay, so now we are going to discuss our topic. And can everyone see my word? Okay, so our topic is are he this is our topics, and I have think a little bit about the outlines of our presentation. And I think I can put it in our line group, and everyone can first read it for a while, and everyone can tell, and we can discuss this later. When you or with me, send it to the line. And send it to the line, and I think everyone can, I don't know, read it for 5 minutes, and we can discuss it later. So we can discuss this till 5 minutes later, and now start the meeting. So I think I'll went through the outlines one point by one point, and if there's any problem or anyone want to fix anything, you can tell me or stop me. Okay, so I think first one we should do the brief overview, and we should first talk about the connection between our topics, the his Mia and the ECG, and later on we should talk about the significance of ECG. And after the overview, we should start to talk about what is ECG and explain how this records the electricity activity and discuss how important it is. And in the last part, we should talk about the challenge and the limitation, so it can connect it to the next part, the AI in ACG, and we can talk about its benefits and advancements. And in this part, we should talk about how, just like our topic, we can talk about how AI apply to the ECG. And and I found out that in here the specific AI algorithm is the CNN. So maybe we can research for more information here. And in this part, there another thing we should talk about is the real-time ECG, because I found out that a lot of people are talking about how maybe there will be a wearable device in the future that we can monitor the ECG anytime, anywhere. And now the Apple Watch is one of the examples, so maybe we can refer in our presentation. And the third part is the how AI improving the ECG diagnosis. And in here, I think we should share some examples. And maybe we can find out the example, one from Japan and one from Taiwan. And the part 4 is the challenge and the consideration. We should think about how the doctor and AI should how they work together and address some concern. And highlight the importance of how the doctor oversight and collaboration in AI supported ECG diagnosis. And the last part is the future direction and the researcher opportunities. And last, we will make a conclusion. I think this is our I think this is the outline of our presentation. So I'm thinking maybe here we can how to say everyone can choose the topic what they want to do and make the research before the next meeting. So here are so I think like maybe the one people can be prepared for the brief overview and the conclusion. And yes.
This is what research doesn't seem to do, right? So I'm interested in section 1. So if anyone,
You say you want to choose the section 1, or
yes, the understanding ECG.
oh, okay. So and I think section 2 can I think 2 people can choose the section 2 because I think in this part, this is our main part that we are going to talk about. So I think 2 people can choose this part. So are there anyone want to choose this section?
I
Okay.
want to do. Thank you.
And who want to? Are there anyone? Oh, okay, okay. And the section 3. And I think section 3 will also need 2 people to prepare. So who want to choose this part?
Cool.
Okay.
I think what about if section 2, one Taiwan student and section 3 is need Japanese student, so the
Also, you say section 2
yeah,
is one Japanese student and one Taiwanese student, and the section 3 is
yes,
also. Oh, okay. So
it's good.
maybe the so
I'll do it somewhere else.
sorry, can you say again?
I'll do another part.
Oh, okay, so you can. And I think I can do this part. Okay, and okay, so section 4 needs, I think one person will be enough. So here we still have. So can Ija do this part?
Yes.
Okay. And the section 5 will be the Chen. Okay, and I think the one who do the brief overview and the conclusion can, who do it can be discussed at the I don't know, maybe next meeting or the last meeting, and we can discuss who will do these parts. So I think before next meeting, what we need to do is just research for the information and I know maybe we can all have some thoughts and we can discuss in the next meeting. And in the next meeting, we can begin to make our presentation. So, okay, so, and now we should decide the time of our next meeting. And according to the because you have give us the time that the time that you can, so you can't join the meeting. So I have arranged these 4 dates. So are there anyone not available in these 4 days? The August 21st, 23rd, 26th, and 28th.
In 23rd and 21st, I can only have the meeting in after 6 p.m.
You say 21 and 23rd.
20, yeah.
Okay. How about others? Are there any problems for these 4 days?
Depends on the time of the day. So, or day I can do, but the I think I can do all the day.
So it is okay for you for all these 4 days. You can join. You can. It is all okay, or are there any problems?
I can't do on 23 and 26.
So these 2 days, the 23rd and 26th, you cannot join the meeting.
Yes.
Or, okay. How about Kurumi? Is it all okay for you for all these 4 days?
I can't join meeting from 18 o'clock to 10 o'clock on 21st and 23rd and 26th.
So 21st, 23rd, and 26th, you all cannot.
And I cannot the meeting 28. I can't from 16 to 18.
So Sorry, you mean
Yeah.
so you're okay on the 28th. You can only have the meeting on the 28th and at this time.
This time I cannot join meeting.
Oh, you cannot. For
Yes.
oh, okay. So it's for 21st, 23rd, and 26th, or only 28th. You mean you cannot join?
From 18 to 21 o'clock.
So you mean from you mean the 21, 23rd, and 26th, you cannot join the meeting at the 16 to 18, right?
18, okay, 18, from 18 to 19, 19, 21 o'clock.
18 to 21. I agree.
Yeah.
Okay, so we can, so if on 21 we can have the meeting at so Kurumi can only join the meeting after 21. Is this what you mean? You say after, or you can only join in?
Yeah. I can join the meeting after 21 o'clock on 21st and 23rd and 26th.
Okay. And this is the Japan time, right? Right. The 18 to 21 is the so
Japan time. And Taiwan times. So
Taiwan time will be 8.
20 o'clock.
Yes. So it is okay for everyone to have the meeting at 8 o'clock on August 21st. Can everyone join at this time? August 21st at after 9 o'clock Japan time and 8 o'clock in Taiwan time.
Okay.
林子安 and 田一佳, is it okay for you too?
Yes.
田一佳, is it okay for you to join after 9? Or after 8 o'clock in Taiwan time at August 21st?田一佳. Okay, so I think well, first I think we decided to have the meeting at this time, and how, so 23rd Kumi is the same, right? You can only join after 9.
Yeah.
But Tanaka can. So how about 28? Can Kumi, is it when can you have the meeting?
I cannot join the meeting from 14 o'clock to 17 o'clock.
You say on 28th, right?
Sorry.
You say the 14 to 17
I can
on
join at 16 o'clock. 16 o'clock to 19 o'clock. Sorry.
You can or cannot?
I cannot
Okay.
join this time.
So maybe you can start from. So I think we can have another meeting at August 28th, and we can start from 20 o'clock in the Japan time and 19 for the Taiwan time, right?
Okay.
How about others? Can everyone join at this time?
Okay.
How about another three, the Hinata and Lin Zi'an and Tian Yingjia? Is it okay for you? Okay, and how about?
Yes.
I can do.
Okay. Okay, so now we make sure that we'll have the meeting at 21 and 28, and I think because I think we cannot have too many meetings, so maybe before the August 21st we'll have to finish all the research. And if you have any problem or anything you want to discuss, you can send the message on the line before the date, and we can discuss it earlier, and we'll start to make the PPT from 21 to 28, and I think we hope that we can finish our PPT at 28, and if not, maybe we'll need to have another meeting at September, and I think the date we will discuss maybe after August, because I think no one was sure are they available at September. So is it okay for everyone? Okay, so are there any other question that you want to ask or say?
I have a little idea of the overview of the report.
Can you say again?
I think maybe we can add a little part that are introduce the erythema before section 1.
Oh, okay.
Just a little brief part.
Okay, and I think this part can be put in the brief overview. So maybe when we decide who will behave for this part, and the person will have to prepare for introduce the arrhythmia. It is okay, Lin Zhan. So we'll put in the brief overview. Okay.
Okay.
So are there any other questions? Okay, so I think it is the end of our meeting. So bye bye.
Bye.
Bye.